Amines, all we have left is to discuss really quick how there's a few things to note when it comes to quaternary amines, okay? So amine salts, this kind of is going to feel redundant to what we wrote right up here, partially, but amine salts, they have the cation and the anion. So when an amine is a cation, we call it an ammonium, specifically cation. So it's got some kind of it's some compound that has nitrogen with a plus charge on it, and then an anion. Okay, now the anion does not have to be hydroxide. It could be a whole slew of things: chloride anions, bromide anions, all kinds of stuff. So like literally the products, what you drew up here, this is an amine salt. This is what we're talking about. You got the cation and the anion. Okay, but we're just going to recognize, hey, we can actually name these. Okay, so remember the rules for naming amines that we talked about earlier. Specifically for like this one, you would name the side that has the more carbons. So this is an isopropyl group. So you would call this N-methyl isopropyl. Now, instead of saying amine here, because it now has the plus charge and it's ammonium ion, let's see what the rule is. Naming amine salts is just like naming ionic compounds. You name the cation first, anion second. I'm going to write that in. Cation first, anion second. This is stuff that you learned way, way, way early in previous chemistry courses. The most complex part is naming the amine cation correctly. So that's what we're about to do. I have that. Sorry, that was redundant. Remember, cation first, anion second. And the amine name ending ends in, or sorry, the anion name ending ends in "ide." So if we were looking at an example, we were going to name this N-methyl isopropyl ammonium. We're recognizing that this is now a cation. You don't say ammonium cation, you just say N-methyl isopropyl ammonium. And then we would name this, instead of bromine, we put IDE at the end. That's how you name anion. So it'd be bromide. Some of you may remember that. It's just been a minute since you've done some of this. Okay, so if it is an ammonium salt, you name it, instead of a name ending as a amine, you put the name ending ammonium to indicate there's the plus charge, and then you name the anion. So this is the cation, and this was the anion. Okay, that's how you name ammonium salts. The reason we call them salts is it's what we call a lot of ionic compounds. Okay. Is we call them salts, cation and anion. All right, so it gives you another example here. Let's say we have this really big, look at that ammonium compound. That looks really hard to name. That is tributylamine when it's just the free amine. No plus charge on that nitrogen. It's a tertiary nitrogen, tributylamine. Okay, there's so many carbons there. It's not soluble in water, so it's water insoluble. Then you got hydrochloric acid. Okay, the amine here is the base. Obviously, it says it's the acid. So when these react, what do we get? Let's zoom in on our product. Now we're going to name this salt tributyl. Instead of amine, we just call it tributyl ammonium, and then we name the anion chloride, tributyl ammonium chloride. Okay, so that's another example. Just a little bit different when you have the ammonium cation versus just the amine. Okay, I want to make a big deal out of this. Coming very soon, coming to chemistry classes near you. In a biochemistry context, you will often see amine salts named by combining the structure and names of the amine, and instead of just the anion, they'll name the whole acid that it's used to form the salt. What does that mean? Give me an example. Well, you see this all the time. This morning, I took an antihistamine. Okay, how many of y'all are familiar with antihistamines? Okay, you get a runny nose, you're a little bit congested. Anybody deal with allergies? I get them. So I took an antihistamine, and on that bottle, it will tell me things like this. Okay, now depending on what your actual molecule is, it won't give you this particular drug name. Might be a different drug. But all this is saying is, instead of calling this something chloride, they go ahead and they just name the acid that was used to make the salt. I don't know why they do that. That's just what you'll see on a lot of prescription labels. And that's what you'll see in the biochemistry. So you don't have to memorize this. I'm not going to ask you to name this like this on the exam. I just want you to be aware if you see this in coming chapters, don't be confused. This is still some kind of amine salt. They're just telling you, instead of they're saying hydrochloride, they're just telling you what acid was used to make the ammonium salt that you get. Okay, so it's exactly this is, by the way, the product of Benadryl. Praise God for Benadryl. That's what I give my kids, and it literally helps them like sleep through the night. So when they get stuffed up, we are thankful for Benadryl. Okay. I know parents, though, this is really sad. If they want their kid to just take a long nap, they'll give them Benadryl. Isn't that bad? They don't need Benadryl. Don't give it to them unless they need it, guys. Okay, quaternary ammonium ions. So this is the last thing here. Again, these ions, they have 4 organic groups bonded to nitrogen. So there is no hydrogen on this nitrogen. You got a nitrogen that looks like this. All R groups, all carbon, some kind of alkyl groups, so they could be aryl groups as well. Thus, they have I'm just going to be lazy, right? Plus charge. And they have no lone pair. No lone pair. Plus charge over here, no lone pair. The lack of these things, because they have no lone pair. You know what? I think that first blank is not supposed to say plus charge. I'm sorry. It's supposed to say they have no hydrogen. Otherwise, this phrase does not make sense. They have no hydrogen bonded to them because it's a quaternary ammonium ion. You can have tertiary ammonium ions. You can have secondary ammonium ions. Quaternary ammonium ions are special. They have no hydrogen and no lone pair. They do also have a plus charge. So the fact that they have no hydrogen, no lone pair, they're not acidic or basic. They can't participate in acid-base reactions. So, guys, heads up for this on the exam. If I say, write the products of these reactions, and I put a quaternary ammonium ion in there as one of the reactants, you're gonna have to tell me no reaction, okay? These are not reactive as acids or bases, okay? So no matter their structure is not affected by changes in pH, the way we're going to see, especially when we get to proteins and side chains, how pH can affect things, whether it's in a free amine position, or I should say state, or whether it's in a ammonium state, whether it's neutral or whether it's plus charge. Okay. So yeah, if I said write me the product of this, NaOH. You would just tell me no reaction. Okay, I don't care what the other reactant is. So I said it's in the presence of a strong acid or a strong base. Quaternary amines are not reactive because they don't have anything to give or receive. Okay. We're just going to do 1 or 2 of these, and then we're going to be done and look at exam 1. So write the structure of the following compounds. So these are ammonium salts. So let's just do A, and let's just do C. So we got butyl diethyl ammonium. And in fact, I don't love the way they wrote the name out here. I don't know why they wrote it this way. Because butyl is going to have 4 carbons in it, right? So I would think they would put N diethyl butyl ammonium. That's the way I would have written it. I would have written it N diethyl. You know what I think they're doing though? I think because it's ammonium, they're naming it ammonium and then they're putting things in alphabetical order. Okay. So I would probably accept either way, N dimethyl butyl. Because this is what I told you earlier. You name it according to the largest carbon substituent. But I see what they're doing. They're putting things in alphabetical order and they're treating ammonium differently. So just so you know, I don't want you to be confused on the name here. I would accept either thing for that name. Okay, but let's draw it. That's what we really want to do. We got a nitrogen in the middle here. And we've got a butyl group. So this is going to be, I'm just going to draw in stick formation. 1 carbon, 2 carbon, 3 carbon, 4 carbon. And then diethyl. is that's 1 carbon, so that's 2 carbons. No, that's 3. Okay, so there's a carbon there and a carbon there. There's an ethyl group and there's another ethyl group. Now, the last bond has to be to what? We've got to have 4 bonds on this nitrogen to give it, for it to be a true ammonium. But we don't have any other carbon groups. So what does the last bond have to be to here?
Is it an H?
Yeah, it's got to be to a hydrogen. So anytime you read a name like this, you're like, oh, I only have 1 or 2 carbon groups here. The rest of the bonds must be to hydrogen if it's ammonium, because we know this thing is a plus charge if it's ammonium. And then bromide is the anion, so that should be Br minus. So highlight, these are my 2
Is that
ethyl.
at the end, or do you?
Go ahead, Maggie.
I said, is that at the end, or would you put?
Yeah, I kind of
put plus Br, or?
you just write it separate to it. It's not bonded to it. Don't write a bond to the anion here. Yeah, do not bond them together. They're not bonded. They're just separate anion cation. You just write it after. You could write plus Br if you want. The main important thing is this, that you write the structure of the cation correctly and that you get the right anion. So highlighted in blue, these are my 2 ethyl groups. And then here is the butyl group. Okay, C, propyl ammonium iodide. So C, I'll do right down here, propyl. So we got N, and then we got a propyl group. So that's 3 carbons, 1, 2, 3. Now, because we only have 1 carbon substituent, the rest of these bonds off nitrogen, we gotta have 4 if it's a true ammonium. Gotta be the hydrogen. So it looks like that. This nitrogen has to have 4 bonds. So there's propyl ammonium, and then iodide we know is the anion form of iodine. So that's I minus. So this was A, and this was B. Now the next part I added this on. On the butyl diethyl ammonium, is this a primary, secondary, tertiary, or quaternary? Just because it has 4 bonds doesn't mean it's quaternary. You gotta count how many carbons are bonded off of this particular nitrogen.
Tertiary.
It is tertiary. Okay, what about the propyl ammonium?
Primary.
Primary.
Yep. So does anybody have questions on how we're labeling? Anybody confused on how we got tertiary or primary? I didn't explicitly walk through that, but it seems like y'all understand.
Isn't it because the nitrogen's only bonded to 1 carbon?
Say that again, Robin.
Isn't it because the nitrogen's only bonded to 1 carbon? So it's
Yeah, on C, on the propyl ammonium. We just have this one, I'll highlight it. We just have this 1 nitrogen carbon bond. That's why it's primary. Up here, I highlighted 3. Well, these 3 bonds right here, 1, 2, 3. Those are 3 nitrogen carbon bonds. That's what tertiary. Okay, that's chapter 16. Any questions as of now?